Download this code from codegive.com, link in the description below. OK, let's dive deep into batch processing in Android. This is a common and crucial technique for handling large amounts of data or complex tasks efficiently without freezing the UI. Understanding batch processing. Batch processing involves dividing a large operation into smaller, manageable chunks, batches, and processing them sequentially. The goal is to avoid blocking the main UI thread, which is responsible for rendering the user interface and handling user input. If you perform a long-running operation on the main thread, the app becomes unresponsive, leading to a poor user experience, application not responding or ANR. Why use batch processing? Improved responsiveness keeps the UI thread free to respond to user interactions. Scalability handles large datasets or a large number of tasks without crashing or slowing down significantly. Resource management prevents excessive memory consumption by processing data in smaller chunks. User experience avoids ANR errors and provides a smoother, more responsive experience. Key components. 1. Data source the source of the data to be processed, example a large file, a database query, a network request. 2. Batch size the number of items to be processed in each batch. This is a crucial parameter to tune. A too small batch size can introduce excessive overhead, while a too large batch size can still block the UI thread. 3. Worker thread, background thread, a thread that performs the batch processing in the background. Async task, handler thread, executor service, and coroutines are common choices. 4. UI thread update a mechanism for updating the UI with progress information or results. This must be done carefully to avoid unnecessary UI updates that themselves degrade performance. 5. Cancellation a mechanism to stop the batch processing if needed, example user cancels the operation. 6. Error handling a way to handle exceptions or errors that occur during processing and inform the user appropriately. Common approaches in Android. Here's an overview of the most popular ways to implement batch processing, with code examples. 1. Async task, simple, but has limitations. Pros easy to implement for simple tasks. Built-in mechanism for updating the UI from the background thread. Cons not ideal for long-running operations or complex scenarios. Async task can be easily mishandled and cause memory leaks. It also has limitations on thread management and concurrency, especially when used improperly. Serial execution by default in older Android versions can be a performance bottleneck. Deprecated in API level 30. Key improvements in this async task example. Clearer batch processing loop uses math.min for safer batch handling when reaching the end of the data list. Progress updates publishes progress updates to the UI thread, showing the number of processed items and the total number of items. Cancellation basic interruption handling is included. You would need to add a task.cancel, true, call somewhere, example in a button click handler, to trigger the cancellation. Result accumulation accumulates results as the batches are processed, providing a summary at the end. Error handling the process batch function now has a try-catch block to handle interrupted exception if the task is cancelled. Explanation of what each part does to enhance readability. Important considerations for async task memory leaks async task can cause memory leaks if it references the activity context and the activity is destroyed before the task completes. Use a weak reference to hold the activity context to avoid this. See more detailed discussion below. Asterisk thread pool asterisk async task uses a thread pool, and the number of threads in the pool is limited. If you launch too many async tasks concurrently, they might be queued and not execute immediately. For more control, consider executor service. Asterisk configuration changes asterisk async task can be affected by configuration changes, example screen rotation. The task might be destroyed and restarted. Use viewModel with libdata to retain the task across configuration changes. 2. Handler thread with handler. Asterisk pros asterisk more control over the background thread and its life cycle. Asterisk cons asterisk requires more code compared to async task. Still need to handle UI updates manually. Key improvements and explanations. Asterisk handler thread lifecycle management asterisk the handler thread is created and started explicitly, and its life cycle is managed with quit safely, to avoid resource leaks. The stop processing method provides a clean way to shut down the background thread. Asterisk clear separation of concerns asterisk the handler for the background thread and the handler for the UI thread are created separately, making the code more organized and easier to understand. This enforces that UI updates happen only on the main thread. Asterisk message passing asterisk message objects are used to communicate between the background thread and the UI thread. This is a standard and safe way to update the UI from a background thread. Asterisk progress updates asterisk the send progress update method posts progress updates to the UI thread, showing the number of processed items and the total number of items. Asterisk cancellation asterisk the process batch function now includes basic interruption handling. When the task is cancelled, the background handler will not process the next batch. It informs the UI to show the task has been cancelled. Asterisk batch processing loop asterisk the handle message for message underscore process underscore batch manages the batch processing loop. It processes a batch, updates the UI, and then schedules the next batch. Asterisk explanation of what each part does to enhance readability. Asterisk error handling asterisk checks the result of process batch, to see if it returned null, indicating cancellation. Asterisk using quit safely, asterisk the use of quit safely, is crucial for ensuring that the handler thread exits cleanly. It processes any remaining messages in the queue before stopping, preventing potential data loss or unexpected behavior. 3. Executor service, more flexible thread management. Asterisk pros asterisk fine-grained control over thread pools, task scheduling, and concurrency. Suitable for complex scenarios. Asterisk cons asterisk requires more advanced knowledge of concurrency. Still need to handle UI updates manually. Key improvements and explanations. Asterisk executor service lifecycle management asterisk the executor service is created and managed explicitly, allowing you to control the number of threads used for processing. The stop processing method provides a way to shut down the executor service cleanly and handle cancellation. Shutdown now is used to interrupt currently running tasks, and await termination is used to wait for the tasks to finish or time out. Using shutdown, instead of shutdown now, would allow the current task to complete its work. Asterisk clear separation of concerns asterisk the handler for the UI thread is created separately, ensuring that UI updates happen only on the main thread. Asterisk task submission asterisk the executor service.submit method is used to submit tasks to the executor service. The future object returned by submit can be used to cancel the task. Asterisk progress updates asterisk the UI handler.post method is used to post progress updates to the UI thread, showing the number of processed items and the total number of items. Asterisk cancellation asterisk the current task.cancel, true, method is used to cancel the current task. The process batch function now includes interruption handling. Asterisk synchronization asterisk The synchronized block is used to ensure that the results list is accessed safely from multiple threads. This is crucial when multiple threads are adding results concurrently. Asterisk error handling asterisk The code includes error handling for the interrupted exception that can occur during the executor service shutdown. Asterisk explanation of what each part does to enhance readability. Asterisk avoiding memory leaks asterisk The executor service equals null, line in stop processing, allows the executor service to be garbage collected, preventing potential memory leaks. Asterisk using a future asterisk The future, current task allows you to cancel the currently submitted task. 4. Coroutines, modern, concise concurrency. Asterisk pros asterisk concise and readable code. Simplified background task management. Good for asynchronous operations. Asterisk cons asterisk requires Kotlin and understanding of coroutines. Key improvements and explanations. Asterisk coroutine scopes asterisk uses coroutine scope, dispatchers.default, to launch the coroutine on a background thread. This provides structured concurrency and simplifies cancellation. Asterisk dispatchers.io asterisk The process batch function uses with context, dispatchers.io, to perform the processing on the IO dispatcher, which is optimized for I/O bound tasks. Asterisk dispatchers.main asterisk uses with context, dispatchers.main, to update the UI on the main thread. Asterisk is active check asterisk The is active property is used to check if the coroutine is still active before processing each batch and each item in the batch. This allows for graceful cancellation. Asterisk cancellation asterisk The job cancel, call in onDestroy, cancels the coroutine when the activity is destroyed, preventing memory leaks. Cancellation exception is caught in the process batch method to handle cancellations cleanly. Asterisk thread safe list asterisk mutable list of int, is used to store the results. In cases where multi-threaded access is needed, consider using a thread safe collection like collections.synchronized list, mutable list of int, or concurrent hash map. In this specific example, the results are updated in a synchronized block, providing thread safety. Asterisk concise and readable asterisk The code is more concise and readable compared to the async task and handler thread examples. Asterisk explanation of what each part does to enhance readability. General best practices for batch processing in Android. Asterisk choose the right approach asterisk select the appropriate approach based on the complexity of the task, the desired level of control, and the target API level. Coroutines are generally recommended for new projects. Async task is deprecated and should be avoided. Asterisk tune the batch size asterisk experiment with different batch sizes to find the optimal balance between overhead and responsiveness. Smaller batch sizes can improve responsiveness but increase overhead, while larger batch sizes can reduce overhead but potentially block the UI thread. Asterisk use thread-safe data structures asterisk when multiple threads access shared data, use thread-safe data structures, example concurrent hash map, copy on write array list, synchronized collections, to prevent race conditions and data corruption. Use synchronized blocks carefully for fine-grained synchronization. Asterisk handle configuration changes asterisk use view model with libdata to retain the task state across configuration changes, example screen rotation. Asterisk provide user feedback asterisk keep the user informed about the progress of the batch processing operation. Display progress bars, progress messages, or other visual cues to indicate that the app is working. Asterisk implement cancellation asterisk allow the user to cancel the batch processing operation if needed. Handle errors gracefully. Catch exceptions or errors that occur during processing and inform the user appropriately. Minimize UI updates. Avoid unnecessary UI updates. Update the UI only when necessary to avoid performance bottlenecks. Use profiling tools. Use Android Profiler to identify performance bottlenecks and optimize the batch processing operation. Avoiding memory leaks, important. Memory leaks are a common problem when using background threads in Android. Here's how to avoid them, focusing on async task and other relevant scenarios. 1. Async task and handler thread. Inner classes and contexts. If your async task or handler thread is an inner class of an activity or fragment, it implicitly holds a reference to the enclosing class, the activity/fragment. If the activity/fragment is destroyed before the background task completes, the async task/handler thread will hold a reference to the destroyed activity/fragment, preventing it from being garbage collected. This is a memory leak. Solution: static inner classes and weak references. Make the async task or handler thread a static inner class. This breaks the implicit reference to the enclosing class. If you need to access the activity or fragment from the async task or handler thread, use a weak reference to hold a reference to the activity or fragment. A weak reference allows the garbage collector to reclaim the activity or fragment if it's no longer strongly referenced. Check for null. Always check if the activity or fragment is still alive, example is finishing, before accessing it through the weak reference. 2. Executor service. Shut down properly. As shown in the executor service example above, it's crucial to shut down the executor service when you're done with it. Use executor service.shutdown now, to interrupt running tasks and prevent the executor service from holding on to resources. Set executor service equals null to allow the garbage collector to reclaim it. 3. Coroutine scope. Lifecycle awareness. In Kotlin coroutines, use lifecycle aware coroutine scopes, example lifecycle scope or view model scope, to automatically cancel coroutines when the activity or view model is destroyed. 4. Broadcast receivers, listeners, and callbacks. Unregister/remove. If you register a broadcast receiver, set up a listener, or use a callback in your activity or fragment, be sure to unregister the receiver, remove the listener, or cancel the callback in onDestroy, or on pause, to prevent the activity or fragment from being leaked. 5. Static variables. Be cautious. Avoid holding large objects or context references in static variables, as they can prevent those objects from being garbage collected for the entire lifetime of the application. 6. General tips. Use context carefully. Avoid holding activity contexts longer than necessary. If you need a context, prefer using the application context, obtained from getApplicationContext, which has the same life cycle as the application and won't cause memory leaks. Profile for leaks. Use Android Studio's memory profiler to detect memory leaks in your application. Lint warnings. Pay attention to lint warnings in Android Studio, as they can often identify potential memory leak issues. Summary: batch processing is a powerful technique for improving the responsiveness and scalability of Android applications. By dividing large operations into smaller chunks and processing them in the background, you can avoid blocking the UI thread and provide a smoother user experience. Choose the approach that best suits your needs and remember to handle thread management, UI updates, cancellation, error handling, and memory management carefully. Coroutines are generally the recommended approach for new projects due to their conciseness and improved concurrency management. Remember to analyze and tune your batch size for optimal performance. This comprehensive guide provides you with the knowledge and code examples to implement batch processing effectively in your Android applications. Good luck.